Hey everyone, welcome back to the deep dive. We know you're here because you want to stay ahead of the curve, cut through all the noise, and really understand the things that matter.
That's right, and today we're diving into a topic that has everyone talking. The Model Context Protocol, or MCP. You've probably heard the buzz, seen the headlines, maybe even skimmed a few articles.
But we're going to go deeper than that. We've got news articles, technical documents, blog posts, you name it, and we're going to synthesize all of that so you walk away with a solid understanding of what MCP is, why people are excited about it, and what it could mean for the future of AI.
Especially for what we call agentic AI, AI that can actually do things out in the world.
Exactly. And we're aiming for that sweet spot, giving you enough depth to really get it without overwhelming you with jargon.
We want you to be able to explain this to your friends, your colleagues, maybe even impress your grandma at the next family dinner.
All right, so let's jump right in. What is this model context protocol everyone's talking about?
Well, in the simplest terms, MCP is an open standard, kind of like a set of rules that everyone agrees on. It was announced by Anthropic back in November of 2024, and the goal is to standardize how large language models, those LLMs we're always talking about, connect with external data and tools.
And I've heard a really good analogy for this, MCP as a USB-C port for AI.
Yeah, that's a good one. Just like USB-C lets you plug all sorts of devices into your phone or computer, MCP wants to be that universal interface for AI applications.
So instead of each AI application needing its own unique way to connect with different tools and data sources.
We have this common standard that everyone can use.
Yeah.
It creates what's called an abstraction layer, like a universal translator between AI and the tools it needs to use.
So the AI doesn't need to know the specifics of how each tool works, and the tools don't need to be custom coded for each AI.
Right. It simplifies things dramatically. And ultimately, as Anthropic has said, the idea is to enable AI agents to go beyond just understanding and responding to language.
So AI that can actually take actions, do things in the real world, not just in the digital world.
Exactly. Things like sending emails, scheduling appointments, booking travel, that sort of thing.
So that's the what and the why. But before we get to the how, I think it's important to understand the problem that MCP is trying to solve. What was the situation before MCP came along?
Well, before MCP, if you wanted an LLM to interact with, say, a database, and then maybe post an update to social media, you often had to build completely separate connections for each of those systems.
So like a custom solution for every single integration.
Pretty much. It was a very fragmented landscape, and as we learned from Tech Talks, it created a lot of complexity and headaches for developers.
Not to mention it really limited what LLMs could do.
Yeah. Imagine trying to build a house where you had to custom make every single nail, every screw, every piece of lumber.
That would take forever.
Exactly. And that's kind of what it was like trying to build AI applications before MCP. LLMs are amazing at processing information, but to be truly useful as agents in the real world, they need access to external information and the ability to actually do things.
And that's where MCP comes in.
Right. MCP tackles this language barrier between AI systems and the tools they need to use. Tools can basically declare their capabilities in a structured format that the AI can easily understand.
So the tools are saying, hey, here's what I can do, and the AI can understand that message regardless of what specific tool it is.
Precisely. It's all about communication and interoperability.
Okay, so let's get into the how. How does this USB-C for AI actually work in practice?
MCP uses what's known as a client-server architecture, which you're probably familiar with from browsing the internet.
Right, you have the client, which in this case is the AI application, making requests.
And you have the server, the MCP server, which manages access to the external resources, the tools, and data. This architecture is explained in detail in the Understanding Model Context Protocol document and the Tech Talks article, if you're interested in the technical details.
So the AI sends a request to the server saying, hey, I need to do this, and the server figures out how to make that happen using the available tools.
That's the basic idea. And within that framework, MCP provides a few key functions. First, there's tool discovery. This helps the LLM figure out which tool is the right one for the job.
So if the AI needs to get the current start price, the MCP server would know which tool can provide that information.
Exactly. Then there's invocation, which is the process of actually calling that tool and telling it to execute a specific function.
Like, hey, stock price tool, give me the price of Google.
And finally, there's response handling, which is how the results from the tool are structured and sent back to the AI in a way that it can understand.
So it's not just about making the connection, it's about making sure the AI can use the information it gets back from the tool. Can you give us a more concrete example of what an MCP request might look like?
Sure. One of the documents used the example of getting a stock price. Let's say an LLM needs to know the current price of Google stock, GOGL. Using MCP, the request might be structured something like this. It would specify that it wants to use a tool, specifically one that can get stock price. Then it would provide the argument, which is GOGL, the stock symbol, and maybe specify that it wants the price in USD.
Okay, so the AI is making a very specific request in a standardized format that the MCP server can understand. And what are the pieces that make up this MCP ecosystem? What are the actors involved?
There are four main parts. You have the MCP server, which, as we discussed, exposes the capabilities of the external tools through the MCP protocol. Then you have the MCP client, which is the software that allows the LLM to connect to those servers.
So the server is like the library and the client is the library card.
That's a good way to put it. Then, of course, you have the LLM itself. That could be a model you access through an API or even one you run yourself. And finally, you have the tools themselves.
Which could be anything from files on your computer to cloud databases to web services.
Yeah, pretty much anything you can think of. And it's worth noting that MCP is flexible in how these components communicate.
Right, I read in the Tech Talks article that it supports different methods like STDIO for local programs and HTTP with server-sent events for web-based interactions.
Right, so it's adaptable to different environments and use cases.
So we've got the server, the client, the LLM, and the tools. And now let's talk about the why again, but at a deeper level. What are the benefits of using MCP? What makes it so advantageous?
One of the biggest benefits, and this comes up repeatedly in the sources we've looked at, is standardized communication. MCP provides this universal framework for interoperability across all sorts of different tools.
A common language that everyone can speak.
Exactly. And as the document, How Does MCP Improve Integration points out, this reduces fragmentation and simplifies development tremendously.
It makes sense. If everyone's speaking the same language, things are going to be much smoother.
Another key benefit is enhanced functionality. By having this standardized connection, LLMs can access real-time data, perform complex calculations using specialized tools, and interact with the world in ways that weren't easily possible before.
So it's not just about being connected, it's about being able to do more to leverage the power of all these different tools.
Precisely. And this leads to greater flexibility and scalability. With MCP, you have dynamic tool discovery. The AI can automatically find and connect to the tools it needs without needing to be specifically programmed for each one.
So if the AI needs to book a hotel, it doesn't need to know about every single hotel booking website in advance.
Right. It can just say, I need a hotel booking tool, and the MCP server will take care of the rest.
That's a huge advantage in terms of making AI applications more adaptable and easier to scale.
Absolutely. And the document on how MCP enhances scalability actually quantifies this. It says that MCP can reduce complexity from ONM to ON, which is a pretty significant improvement.
Well, I'm not a mathematician, but that sounds impressive.
It is. And on top of that, MCP supports modular and reusable components, which saves developers a lot of time and effort.
So you can build an AI application like you'd build with Legos, snapping together different modules?
Exactly. It's a much more efficient and elegant way to build things.
And it's not just about ease of development. There are benefits for the end user as well.
Right. MCP ensures cross-platform compatibility, so AI models can work seamlessly with services in the cloud, on local servers, and even on internet-connected devices.
So it doesn't matter where your data is or where your tools are running.
No, it all just works together. And it offers real-time adaptability, so AI systems can process and respond to live streams of data.
So it's not limited to static data sets. It can handle dynamic, changing information.
Exactly. And because the communication is standardized and much of the integration is automated, the ongoing maintenance is much simpler.
So less headaches for the people managing these systems.
Definitely. And we can't forget about security. MCP includes built-in security features like encryption, access control, and frameworks for regulatory compliance.
Which is critical as AI becomes more powerful and more integrated into sensitive areas.
Absolutely. And it also allows for faster deployment at scale because the underlying architecture is streamlined and you can leverage pre-built integrations.
So it's easier to get these systems up and running and to scale them as your needs grow.
Right. And the open source nature of MCP encourages community involvement, which drives innovation and leads to a richer ecosystem of tools and integrations.
So it's not just one company controlling the direction of MCP, it's a community effort.
Exactly. It's a truly collaborative effort.
Okay, so we've talked about what MCP is, why it's important, and how it works. Now let's talk about the future. What's the current level of adoption, and what does the future hold for MCP?
Well, we're already seeing some promising signs of adoption. Companies like Block, formerly known as Square, and Minio are using MCP in their products and services.
And Block's CTO, Donji Prasanna, had some really positive things to say about it.
Yeah, he said that MCP helps them remove the burden of the mechanical so people can focus on the creative, which I think captures the essence of what MCP is trying to achieve.
To make AI development more efficient and less about the plumbing and more about the possibilities.
Exactly. And it's not just smaller companies. Major players like OpenAI are also supporting MCP.
That's huge. Having those big names on board gives MCP a lot of credibility.
Right. And there's active development happening around MCP. People are building pre-built MCP servers for popular systems like Google Drive and Slack, which will make it even easier to integrate AI with those tools.
So it's not just a theoretical concept, it's becoming a practical reality. But what do the experts think? Do they believe MCT has the potential to become the standard way of connecting AI with the world?
Well, Anupam Datta, a well-respected expert from Snowflake, was interviewed for one of the articles, and he expressed optimism about MCP.
So he sees the potential.
Yeah, he said that it's still early days, and wider adoption will be key, but he acknowledges that MCP is addressing a very real and growing need.
That need for interoperability as AI agents become more sophisticated and more integrated into our lives.
Exactly. And the co-founder of Minio, A.B. Piriyasamy, offered a really interesting perspective on how MCP helps AI. He's the example of an AI trying to book an Uber for your child.
So the AI knows how to book an Uber, but it doesn't know your account details or who your child is.
Right. It's missing that crucial context.
Yeah.
And MCP provides a standardized way to share that context securely.
So it's not just about the mechanics of connecting to a service. It's about providing the AI with the information it needs to make smart decisions.
Precisely. And we're seeing other companies like Elation, Cloudflare, and DataStax actively building on top of MCP, each finding unique applications for it.
So the ecosystem is growing, and companies are finding creative ways to leverage MCP.
Yeah. Cloudflare, for example, has even announced a remote MCP service designed for less technical users, which is a great step towards making MCP more accessible.
It seems like the fact that MCP was one of the first open standards to address this problem is giving it a real advantage.
Yeah, as one of the sources concluded, MCP has a significant early lead in the race to become the standard for agentic AI. It was first to market, and it has growing support from both large and small companies.
So unless a really compelling alternative comes along soon, MCP has a good chance of becoming the de facto standard.
It certainly seems that way.
Well, I think we've covered a lot of ground in this deep dive. Can you summarize the key takeaways? What are the most important things for our listeners to remember about MCP?
The key thing is that MCP is a big deal. It's a significant development in how AI models interact with the outside world. It provides a standardized and scalable way to connect AI with tools and data, moving us away from that messy world of custom integrations.
And it really does seem like the USB-C for AI, a universal connector that will make AI more powerful and more versatile.
Exactly. And that has the potential to unlock a whole new wave of AI applications, especially in the area of AI agents that can act autonomously in the real world.
So as you think about what you've learned today, consider this. How might this standardization in AI connectivity speed up the integration of AI into the tools and services you use every day? What new possibilities might arise from a more interconnected AI world?
It's a question worth pondering because the world of AI is evolving rapidly, and MCP could be a major driving force in that evolution.
Thanks for joining us for this deep dive. We'll see you next time.